Hello and welcome to another episode of the CG Garage. This is episode number 412 featuring Jonathan Egstad, who I have known for many years, or at least I knew him many years. I've been out of touch with him, but it was great catching up after a long break. He is, I'm going to call one of the OGs of Nuke. And really knew compositing and sort of help build that entire workflow for not just a digital domain at the time, but now Nuke has become sort of like the de facto compositing package that a lot of visual effects industry uses. And so Jonathan really sort of laid that landscape out there, especially in the 3D sense of Nuke. So it was really cool to be able to talk to him and catch up with him. Super nice guy. He's currently at the Foundry doing some great stuff over there. But Kristen, what did you think of Jonathan?
Yeah, well, I refer to him as the Nuke Master, and also an Academy Award winner. And he's just worked on some amazing films, Apollo 13, Titanic, and I, Robot with You. That's where you guys met, DD. Yep. And like a lot of people we've had on the podcast, he kind of moved to LA on a whim. And in his case, it was for his animatronic dreams, but then moved on to CG. So you guys get into a lot of specifics in this podcast, which I'll let you discuss and everyone can hear. But he's worked at DD, DreamsWorks Animation. He goes into like remote working during COVID and then his new role at Foundry. So it's a great podcast. And you guys, of course, get into machine learning and then the future of Nuke. So
very excited stuff. I mean, I've always been a fan of Nuke. You know, when I first started, it was a very intimidating package for someone who didn't really know much about compositing at all at the time, because you just open it up and it was just a gray slate with nothing there, and you just start with just a node. But it's obviously grown quite a bit, and it's, like I said, very important part of it. And it was really cool to have him on. The last person I've had from the Foundry on the podcast was Jody Madden, so it was really cool to have her on back then. You could go check out that episode. But yeah, really exciting to have Jonathan on, and super happy that we were able to finally catch up after many years. All right, we don't have any product announcement right now, but we got an event that's going on for quite a long period of time. Kristen, tell us a little bit about what's happening.
Yeah, so you can find this at chaos.com/events. So this is actually, it started on January 31st and it will go to March 30th. And it is a recording that you can watch of tools and techniques to visualize an eco-friendly home. So you can learn how to render an animated virtual tour with Chaos Vantage and V-Ray 6 for SketchUp. So a lot of fun stuff, and it'll be a recording. So access it until March 30th. So
perfect. Lots of cool stuff to do there. So if people want to know more about the podcast, Kristen, where can they go?
You can go to facebook.com/CG Garage Podcast or chaos.com/CG Garage. And if you'd like to watch us, go to youtube.com/Chaos Group TV.
Of course, if you have any other ideas or questions about the podcast or comments, you can always leave us an email. labs@chaos.com is where you can do that. People have been leaving us ideas. You guys know I'm on a mission to find more people that want to speak about machine learning and AI and art and how it's affecting all of our lives, for better or for worse. So please give us some great ideas. We did reach out to a couple people that were suggested in Labs, and we really appreciate it. So remember, that is labs@chaos.com is the email you can suggest us those ideas. But for now, please enjoy episode number 412 with Jonathan Egstad.
Welcome to another CG Garage, where the Chaos Group talks. You'll know it's over when the last bucket drops. We're gonna fire off rays in high dynamic range. We know that ambient occlusion is passé. Global illumination won't lead you astray. And while image-based lighting is really swell, you need to make sure everything has Fresnel.
It has been a long time since you and I have worked together at the very least, but actually we've seen each other here and there at conferences and a few other things.
Sure.
So it's been nice, but I've actually wanted to have you on the podcast probably since the very beginning. Which is over 8 years that I've done this. So I'm very excited because I think that you've sort of had a believe it or not, a very important part of my education in terms of computer graphics. I learned by fire, as I say, in terms of color space and understanding a lot of that stuff when I was working on iRobot with you. And I was really, really appreciative of that time. But let's go a little bit before that. So what got you into computer graphics? What was the thing that sort of catalyst that got you involved in this industry?
Well, it was kind of a weird transition because I got into it because of Jurassic Park, but not because of the reasons most people get into it because of Jurassic Park. I actually came out to Los Angeles to get into visual effects to do motion control and animatronics. That was what got me going. Is I loved mechanics. I loved the computer controls of those. So for me, computer graphics were an interesting thing, but not like something I wanted to do. So what I really wanted to do was build creatures. And so to come out to LA, I built a motion control system using my Amiga, and I built an interface box to control motors, servo motors, and a friend built a little puppet, and I kind of came out to LA saying, "Hey, look what I can do," kind of thing. But that didn't get me a job immediately, and so.
And what year was this approximately?
This was 91. So this is 1991.
Okay, so yeah.
So I kind of did the whole California or bust thing. I came out to LA, with this and going, okay, I'm going to find a job, no problem, right? And I did find a job, but it was in kind of what I was already doing was video engineering. So I got a job at Pacific Ocean Post through an acquaintance. But still, I was like, I wanted to do visual effects, right? So on the side, a friend of mine was working for DreamQuest. And so he and I collaborated. I took my Amiga animatronic recording system, and we did this little test of a running dinosaur puppet. And so I built a mechanism to do that. It was just an armature with a very simple little foam head. So it was just a test. And we shot it on 35 mil on like 15 frames per second. We puppeteered it. And the idea was, it's like, hey, we had heard that Jurassic Park was going to be doing, animatronics or motion, stop motion, and go motion for the dinosaurs. And so I was like, ooh, maybe there's some, possibility there. We finished this little test, and we got it together. We slapped it over the background of back of a truck, shot off the back of a truck, and we showed it to Hort Yateman and the others at DreamQuest, and they're like, "Oh, that was really cool." Less than a week later, after we showed that tape to them, word came down from ILM that Jurassic Park was no longer being done by GoMotion. It was being done in CG. And that was just like this, that was this moment where I realized that, oh my God, my whole reason for coming to LA and getting into visual effects, all of a sudden I could see, this brick road hitting this brick wall.
Right.
So that's when I changed gears and got more into CG. And then, but that didn't really come about until a digital domain. Okay.
And how did you, so obviously, I mean, it's interesting you brought it up because I've been following the story from the other side, and in terms of I was watching Jurassic Punk and the story of Spaz Williams and how all of that happened. So to hear how that affected you in some ways is kind of an interesting thing, right?
It was significant. It was profound because I realized that I had gotten into the industry kind of at the tail end of the generation that had come before, so the 80s was all about motion control and the refinement of it, and just the high watermark of what you could do in motion control and that type of optical compositing. All those movies in the 80s were just unbelievable. But that was kind of this tailing out of that technology. They kind of hit the peak, right? And this was the tail end. So around about that time, Apogee, for example, went out of business. Boss went out of business. So all these fundamentally, these important companies to visual effects in the 80s and all that technology were kind of dying on the vine. right?
Right.
So digital domain seemed like better than like, optical compositing domain, for example.
Right.
Right?
Yeah. But I mean, obviously, you've had a lot of, you were doing a lot of stuff with computers. I mean, you had your Amiga back then. So, how was that transition to computer graphics from just, programming animatronics?
Yeah. So, I mean, up to that point, like I said, done very little. I was programming beginning in the very early 80s. I started with the ZX81 and then Commodore 64 and then Amiga. And all along the way, I was doing, spinning wireframes and just learning how to do those kinds of 3D, but with nothing, nothing more complicated than that. So my main goal was really
Right.
using it to do, animatronics and go motion and motion control. So it wasn't until getting to digital domain and then getting involved in silicon graphics, right, and what you could do with those systems, that all of a sudden this, started to open up. And really Flame, I think, was the beginning of that, because I didn't understand how TDI renderers worked, or any of that. I had no experience in materials or shading or modeling or any of that stuff at all. No production experience in that.
Sure.
So for me, it was about, at the time, I was working in video engineering, so I was dealing with flames and Quantel systems and images, right? Images with alphas. So that was, for me, that was computer graphics, was images with alphas, which is just compositing, right?
Right.
So how you get me those images, whether they're rendered in a computer or whether they're photographed or scanned or whatever, to me at the time, I wasn't involved so much in the CG or the CG part of it. That wasn't my wheelhouse. So, but I got an opportunity to get more involved in the actual production, because up until that time I was just doing engineering. I got the opportunity to composite at night on Apollo 13.
Oh, and what were you compositing in?
Flame.
Flame. Okay.
So I could run the Flame just as an engineer. I knew how to do it. I knew the the ins and outs of how to manipulate it and maneuver, and I could do basic things. But I didn't know any of the production techniques. I didn't know how to color correct. I didn't really know how to key. So Apollo 13, Price Pethel, who was the head of compositing at the time, gave me the opportunity to do that while I was still the video engineer.
Right.
So I was working two jobs. And that turned out to be fantastic. That was really an eye-opening experience for me, that learning production on the fly, with other people like Brian Grill and Carrie Vallejos. I don't know if Carrie Vallejos was on Apollo 13, but those kinds of people who were also learning at the same time. We were all kind of this merry band of people who were working at night, kind of working on these the side shift, and just absorbing, learning.
Right. Yeah. Okay. It's interesting. Those are ideas. I've had Brian on this podcast too, and he was telling the same little story.
Yeah.
Working at night, doing that, and then during the day, doing whatever he had to do to make ends meet.
Exactly.
Which is interesting. But that's really cool. So you, I mean, when I knew you, you'd been, it was, when I started at DD, Nuke was still its proprietary software. It was just going to become a commercial product.
Yes.
And you were very involved with Nuke at that time. So how did Nuke become part of your history at Digital Domain?
Yeah, that was another kind of happenstance experience. Up until I guess T2-3D, I guess, something like that. Nuke was being used for relatively little. It was really for layering together like CG, and as a utility thing for the guys who were doing the rendering and modeling. So up until it wasn't being used for hardcore compositing until T2-3D, because then we had to do stereo, and we couldn't pull off that in Flame. We had to do that in Nuke. And so that kind of pushed us a little bit farther. And at the time, we were doing the vast majority of our work in Flame still at that point. And Nuke was this side tool that we used. And so our primary interface was Flame. And we had a little tool called Flame to Nuke, which would take a color corrector or a action script, and it would convert it to a Nuke script, and we could run it on the farm rather than just being stuck in the Flame. So it was this natural transition towards moving more and more towards Nuke, because we were kind of pushing the limits of what we could do in Flame. And then all of a sudden, it's like, oh, well, if I go to render something at Flame at film res, that could take hours, right?
Right.
And I can't put it on the farm. I have to do it on my local machine. So Nuke could run on the farm. And so for that reason, we were motivated to get more stuff going in Flame. I'm sorry, in Nuke.
Nuke.
Yeah, so really, it was that gradual process of moving more and more into Nuke until Titanic, where almost everything was in Nuke because the shots were so big and so complex. So Titanic was, kind of like the high watermark, just like motion control went through that. It was like that for Nuke 2, it was that point where we had pushed it as far as we could go, and we needed to expand. We needed to evolve. And we knew we needed more power. We wanted to have more Flame-like capabilities, but in Nuke. And so that really was the motivation for, moving on to the next version of Nuke. But for me, the involvement was as a user, learning how to use it and become more proficient at it and understanding its weaknesses. And then getting a taste of changing it as a piece of software, as a piece of engineering, and making it do something that it didn't do before, and that was like a drug for me,
Right.
because at the time, I think this is around Titanic time. Bill Spitzak, who is the primary engineer for Nuke, he was actually working as an artist. Because there were some political issues with the software engineering guys at the time. And so he was working as an artist. And I had run into this problem with Nuke where you would change frames and it would take 30 seconds to a minute for Nuke to just change frames. You couldn't, it was almost unusable. And so I was like, what's wrong? Well, how can we fix this? And he's like, I don't know. Here's the code. Figure it out. And I went, okay. I was motivated, so I put print statements all through the code.
And had you programmed before a lot? I mean, where was your programming experience?
I didn't program a lot. I had done like Modula 2, which is like the next version of Pascal. That was it for me. I never programmed in C. It was like machine language, basic, then Modula 2, and that was about the extent of my programming. So I was by no means an expert programmer, but I had done it enough that I wasn't fearful of it.
Okay.
So I was just like, okay, I know what a print statement is. I can put print statements in. And I put enough in the code to find where it was, when I hit the frame change, it would spew out millions upon millions upon millions of lines of print statements. I'm thinking, I think that's the problem. So once we found it and discovered it, I was like, oh, okay, well, it was actually relatively easy to fix, but that was just like, shooting up. It was like, oh my God, I can change how the program worked. That's so cool. And that was like the snowball. So after that, Nuke 2 transitioned to Nuke 3, and that was not an easy transition. Because we had to convince the management, like Scott Ross, to fund a new round of Nuke. Because at the time, Nuke was perceived as, it was done. it was a working system. Why did we need to re-architect it, right? So what was the reason behind why we needed to re-architect it? And those reasons really came out of Titanic and our experience on Titanic.
Interesting.
So,
Interesting. But besides Flame, there was no real viable compositing package
There was
out
there
there.
was there was Shake. That was the other. That was the other,
Okay.
and there was Chalice, I think, and a couple others, and Composer.
Right.
But really, Shake. It was Shake and Flame. Shake for doing film res procedural stuff, like like Nuke was capable of doing. And we
Sure.
we evaluated it. So Scott was like, well, prove to me, that we need to, and at the same time evaluate what else is out there, because we can buy something. And so we looked at Shake and we evaluated it and we're like, okay, well, this is nice and this is nice and this is, so it has some tools that we didn't have, but it didn't evolve us. It was like a lateral move. It had essentially the same capabilities with a couple more tools, but it wasn't a step up. And we were looking for a step up. And really what was missing out of Nuke and missing out of Shake was a 3D system, a 3D viewer,
Okay.
and more than 4 channels.
More than 4 channels.
It was
that
really
was the big one.
That was the two big things, right? And
Right.
more than 4 channels being probably more important than the 3D system.
I think that when we were on iRobot, and you can correct, you probably know better than I do, but I think we had 64 channels.
We did. We had
capable.
just expanded it to 64 because it was
Right.
at 32 at the beginning.
Right. And it's
and-
64, and we still, because iRobot was like, well, let's just see how many more channels and layers we can add in there. And then it turns out that 64 was, we maxed it out pretty
Surprisingly,
quickly.
yeah, so quickly. It was amazing because all of a sudden we started to use OpenEXR. So OpenEXR was brand new at that time, right? That was the first show we'd ever used OpenEXR on.
Yeah.
And we were creating packed EXRs, which I don't know if it had been done before, but that was certainly a first for us, where we were taking RenderMan renders, which were at the time just 4 channels or AOVs, but you couldn't like name the AOVs with a unique name. They always came out red, green, blue. Even if it was diffused, it would be red, green, blue. And then we would read those into Nuke, into a combiner script, and then shuffle all the channels.
And then re-architect it into different layers. Yeah.
Yeah, and then spit out a combined OpenEXR with all the channels. And we called those if you remember, we had the StuntBot pack, and we had the HeroBot pack, and those were the different, combined channels. And so it gave us diffuse and specular, but also the different layers, the mechanism versus the plastic, and so we could do diffusion, and it gave us depth, all sorts of additional channels.
Yeah, it was very, very educational for me. I mean, it was the first time I'd ever done anything like that, and it turns out it was one of the early times we'd ever done anything like that at DD. But it was, outputting not just red, green, blue, and alpha. It was outputting that plus a ton of different utility layers that would come out of it. It was, what was interesting is I remember, like you said, RenderMan did not have the capability of doing everything at once. So when we were doing preview renders, we were only looking at RGBA. And then when we hit go, it would output this ridiculous, crazy amount of stuff. And then Nuke would sort it out for you. But we had developed some pretty elaborate Nuke scripts to sort of create this incredible illusion that nowadays is much simpler with just pure ray tracing.
You get it for free now, right?
But back then it was just these crazy scripts, and I think it was the MakeBot script specifically that we did that. Now, you were working on the MakeBot script? You figured out a lot of how to make this work, right?
Yeah, myself and a few other people. I mean, I was the DFX, digital effects supervisor on the show, and I'm of course forgetting who exactly was the other supervisors on it. My memory is so bad for people.
Well, see, Lou was on it.
Lou was on it.
Eric Nash was the VFX supervisor on it.
Right. Yep.
And who else was on it? There was a bunch of other people.
So we ended up with these what we called the MakeBot gizmos, right? We had one for the stunt bots,
Right.
which was a simplified version, more like background characters, background bots. And then we had the
Mm-hmm.
hero bot, which was for like Sunny, the hero
Mm-hmm.
robot. And yeah, there was a lot more channels for Sunny than those stunt bots in the background. And we needed it because at the time we couldn't do true photorealistic rendering. I remember talking about having the robots walking down the hall, and they're walking down a hall under all these different lights that are, different lighting fixtures, and asking, oh, we'll have it walk in and out of these pools. And they're like, no, we can't have it do that. I'm like, what do you mean? I mean,
Right.
the specular, can we have the speculars moving properly? No, we can't do that because it's just an environment map. So it's like one, it's one
Oh, right, right, right.
environment, and it's going to follow the bot along. And it's like, oh my God. So that was, again, with my not big experience in CG and not understanding some
Right.
of the limitations of that stuff. I didn't really understand the implications of it.
Yep.
So, but we were able to composite our way out of it, and that's the main story of iRobot, is us learning how to really get a big step up in photorealism because we were experienced enough compositors that we could. I mean, we had good lighting, but just the renders at that time just were not adequate enough to get us that photorealistic look, and it required a lot of manual futzing to get it to look good, right?
Yeah, and just to give people a perspective, especially those who are listening who know ray tracing stuff. I mean, at the time, ray tracing was just not in the vocabulary of what was possible because it wouldn't be able to happen. So we needed to have this sort of semi-translucent shell that was on the robot, which you could sort of see through. And the idea was we wanted to get the effect that you would get when you would have a sort of a glossy refraction pass inside. And what we gave Nuke was a pass where you just saw the transparency of it just as it was. And then also give it a pass where it had the vector distance between the metal inside and the outside of the shell.
Exactly.
And then we would blur it based on that distance that we would have, and it totally sold the effect. Totally sold it.
And the blur was like super simple. It was like that was one of the slowest things, doing a per pixel different blur kernel size was not terribly fast at the time. So we just had a network of different blur sizes that it would switch between, it would blend between depending on the Z distance, right? And so there was a lot of hacks in there to make it efficient and fast. And that was really the goal, was that it allowed us to. It was one of the first films that we did more than like 400 shots in a very short period of time. It was a lot of work in a short period of time, which we weren't used to doing that at the time. And so we really had to find ways of making us being able to like get these renders out and look good quickly, which was difficult to do at the time.
Yeah, for sure. I think the one thing that was interesting to me as well was, we actually spent a lot of time up front getting this system to work.
Yes.
And there was concern. I remember, Nancy Bernstein was like, you guys aren't pumping out the shots the way you should. You guys are behind schedule. It's like, don't worry. And then suddenly like the machine just worked like, whoa, like everything came out at once. And it was like, oh my God, you guys are way, it was, once we got that machine, that fine-tuned machine working, it was absolutely incredible, the output we had on that show.
Yeah, it ended up being a really big thing, and it transitioned right into stealth, kind of using the same methodology, right? Using the same kind of notion. I think they coined the term sham positing.
Yep.
I think Chris Harvey had that term, sham positing, which is, we're
shader compositing.
But it's actually shader compositing. I mean, we're trying to synthesize reality with, a creative eye, I guess is the idea. It's like there's only so much we could do at the time to make it truly real. We couldn't really do real GI, for example, so we needed to fake a lot of those GI effects. So,
right.
Yeah.
Yeah, it was really, really interesting. And we had really great names, like MakeBot was a really good one, but we also had Shampositing, and then the gizmo we had for stealth was Pimp My Jet, I think it was called. So which was really cool. That's was back in the day when Pimp My Car was a popular show on MTV.
Right.
Well, this is, I mean, like I said, it's like I learned so much from that process because, again, while while I did know a lot about CG, I didn't know anything about compositing. And so I learned, it was on a reverse for me. I was like, oh, how does this all come together?
Right.
And the thing that fascinated me, and I think I remember having this conversation with you back in the day, was like when I realized that compositing is actually just math. It's just A plus. It's multiplications and additions. It's really, and I started was like, wait a minute, this is just math. And being a math person myself, I was like, oh. And it just started to click for me. And I just really started to understand like, this is cool because then it's like, oh, how does this add to this and plus this? And then you add this and then you get the end. So it was really cool. But you stuck, I mean, you were very, you were involved in a lot of stuff that in terms of the innovation that was going on at DD. You were still very involved with the development of Nuke. Some of the big people the people I always reached out to when I had a major Nuke questions were either you, Bill Spitzak, or Rob Niederhorst. And if I usually wanted the joke answer, I would ask Rob Niederhorst. Yes. But I remember like that was sort of a really big, important part of my education. I really wanted to thank you for helping me through that process.
No worries. Well, I had a huge education from the other side, especially when developing the 3D system for Nuke, because I was a neophyte when it came to that stuff. So, just what the idea of what I thought lighting was, for example, was completely blown away during iRobot. It's like I had no idea what lighting meant until iRobot, and then I left Digital Domain and went to Image Movers, and I had even a worse concept of what lighting was until I got to Image Movers, and I had to do it in feature animation. It was like, oh my God, the lighting we did at Digital Domain was like a drop in the bucket compared to the level of complexity that you have to do for. So it's this learning experience of just opening my eyes like multiple times. It's like, oh my God.
Well, let's talk about that transition. So give people an idea of what Image Movers was and what brought you to going there. Well,
so I was working in production. My first compositing job was on Apollo 13, like I mentioned, and then I did more compositing. And then I was given an opportunity to be a compositing supervisor on Fifth Element, and that was a huge. It's like, what do you mean? I've only been compositing for a couple of years. I'm going to be a supervisor. There was a big, So it was this nonstop. Like every single show, every year was this another show, another step up, another complexity level, and it just kept building and building and building and building and building, until by the mid 2000s, I was getting fairly burned out. The last show I officially supervised was Eon Flux, which I co-supervised with David Prescott, and that was 2005. 2005, I want to say. By that time, been going like 100%, 110%, fast. So I needed a break. So by the time like 2007 rolled around, I decided to take a break and just like take a, what do you call it? A sabbatical, right?
Sure.
And so
I remember.
Yeah, I left DD for about a year. I went to work with on the Avatar test for a short period of time, actually, which was interesting.
Right.
And then I ended up at DreamWorks for about 6 months. Darren Grant, they needed a little bit of color help, so I did that. And then during that time, Digital Domain got bought, right? So
that's right.
It became Digital Domain 2.0 in that year, and so I decided to come back to GD because they asked me, are you interested in helping productize Nuke to get Nuke, out into a bigger product? And I was like, yes, I am.
Right.
So I came back for that, and I came back to do a little bit of color work, but I was no longer doing production, actor production work.
Okay.
And then Image Movers kind of came out of left field, and it seemed like the opportunity I was looking for because it was feature animation, and feature animation is production, but at a far lower intensity, right?
Right.
And so that was, and I wanted to leave LA and take a break. So that was up in Northern California in Marin County. So I did
Right.
that. So in 2008, went up to Northern California, and
I
was
think
that,
Sonia Bouchard was up there too, right?
yeah, she came a little bit later.
Yeah.
Yeah, we ended up working on Christmas Carol and then Mars Needs Moms, and then Disney shut it down.
That's right.
But it was a
And this
very
was
exciting.
Zemeckis' group, right?
Yes, it was a very exciting
Yeah.
couple years. It was a kind of a dream come true, kind of, or it was a startup, and it was a startup consisting of all these great people from all different companies that around California mainly. ILM and Disney and Sony and Digital Domain and Tippett and you name it. It was like so it was a really good group of people coming together to start this company up from fresh. So you had this blank slate where, I couldn't certainly say that I was an expert at lighting, but here's a bunch of people from ILM who are, right?
Right.
And so I think we had a great group of people who had some amazing talent, and it all came together and gelled. And so, the movies we made weren't necessarily the best, but the production system that we put in place was actually quite impressive and very efficient, and worked really, really well for the short period of time that we were able to do it. It was put together very, very quickly.
Right.
So
Yeah, it was interesting to think about where that, I think it was ahead of its time, because obviously, Zemeckis had some feedback about, how Polar Express looked,
Yes.
and some of the other things. But I think if you look now, it's like people are actually trying to do exactly
yes,
what was being done then.
well, certainly Avatar.
And they've got better motion capture techniques. They've got a few other things that have caught up, that some of the technology has caught up to the idea. So that concept of virtual production and what it meant is very much alive. Just for God's sake, just look at Avatar right now, right? Avatar was a similar technique.
It was, and like I said, I was on the Avatar test for a brief period of time in 2006, I guess it was. So I had seen, where they were, and then it wasn't a matter.
Right.
It was like a year and a half later, and I was starting at Image Movers, and where I started was at the Playa del Rey facility where Digital Domain is in now. That building was where Image
that's
Movers
interesting.
was, right? So their motion capture stage, that was the Image Movers motion capture stage.
I didn't realize that. Yeah.
I walk into that building, and like the first thing I see, the first door to my right, I look in and I see all these like mannequin heads, foam mannequin heads, with these head video recording systems. What do you call them?
The head mount.
The head mount,
cameras,
head mount recording, right? And I was like, wow. And I went in and looked at them, and they were really polished. They were very professional. I mean, they looked really well done, industrial design, like this was like third or fourth generation. And what I had just seen at Avatar was they could barely get a lipstick camera stuck on a aluminum tube. And I was like, oh my God. So Bob had such a head start on this. He had gone to such level of refinement, and but realistically looking at it back, it was really the projects just were lacking, right? The projects he decided to do, I think, he was too ambitious.
Right.
But
right. I mean, he's still an amazing filmmaker, and I still appreciate all of the amazing things he's done. I mean, I've learned a lot. I was at what did I just watch the other day that I hadn't seen Contact. I saw Contact, and it's just such an amazing film. So
it's
he's
fantastic.
just a great. Yeah.
Yeah, it was great to work with him for that short period of time. And the eye reflections, we were extremely attuned to that. When we started,
this was something that we were obsessed about in iRobot, that we had to get eye reflections just
and we
perfect,
didn't, because it turns out that, in fact, you can see it in my eyes now. I've got these fairly large area lights. Essentially, there's a circle light. We did our first test with Scrooge in where there's a candle. He's lit by a candle. He's sitting at the desk, And so we were doing these first tests, and we thought that looked pretty good. We were, we had got the eye reflections in context. Bob did not like them. He was like, I don't like the eye reflections. And we were like, our adrenaline, like, it's like an adrenaline hit, like, oh my God, what do you mean you don't like them? It's like,
right.
And he's like, I don't like them. The problem was that he couldn't necessarily quantify what it was about them that he didn't like. And we did a bunch of tests, and it come to figure it out that we weren't simulating the physical size of the light. So he was expecting to see, like a window shape, like a square shape,
right.
or a gobo, or some shape. And what he was seeing was a point.
Right.
And then as the camera pushed into Scrooge, that point just stayed the same size. It didn't grow bigger. Yep. And so there was a physicality missing because we were just doing standard, for that time, standard specular calculations.
Right.
And it was like, and so we thrashed and we went, oh my God, until we finally figured out. We did a bunch of tests, we got some bunch of footage, and we realized that he was missing those big window shapes in his eyes. Yeah. And so once we got that,
actual reflections.
Yes, actual reflections. So then we were like, oh my God, I think we dodged that bullet,
Yeah. Yeah. Yeah, it's interesting. I do remember, when the revelation when I realized as a lighter that specular and reflection are actually the same thing, and that specular is just a cheap reflection.
Yes, correct. Yes.
So, but anyway, it was interesting to think about that. Okay, well, that's fascinating. So you were at Image Digital, and I think you went to DreamWorks after that. Is that correct?
Yeah. So Disney shut us down, and so but conveniently, PDI was just south of San Francisco. And Darren Grant was there at the time. And so they had just purchased Nuke, months, literally, or a month. It was right at the time. And so Darren was looking for help to help get Nuke integrated into DreamWorks production system. So that's what I came over to do, and spent a lot of time writing a lot of custom tools for Nuke that were attuned for feature animation. Some of them had already experienced with Image Movers, but DreamWorks was even, another level of complexity, and they had some very specific needs. So, and Nuke wasn't designed to work in feature animation. It wasn't designed to work so procedurally. It was really intended for shot production with an artist.
Right.
So there was a lot of stuff that needed to be refined to tune it for PDI DreamWorks' workflow. So so I stayed there for 10 years.
10 years, yeah.
Yeah, we moved. My wife got tired of the fog in San Francisco. So we ended up.
You moved down to Glendale area?
We moved to Glendale, 2003, I think.
Okay.
And then I went to work for DreamWorks in Glendale, and then stayed there until, just 2 years ago.
Wow. Okay. Yeah, you were there for a long. I think you worked with when Nancy was there as well, and David Prescott, and a lot of. Did you work mainly on the in terms of developing the compositing thing, or did you actually do production work as well?
No, I never did production at DreamWorks. I was kind of given the option of what I wanted to do at the time, but they needed so much. They needed so much technical work that I decided I wanted to focus on the engineering part. So rather than try to split my time. So I ended up getting stuck in this engineering slot. So I no longer, at Image Movers, it was great because I was, like Digital Domain, I was kind of splitting my time between being the compositing supervisor and building tools, right? And it was that I really enjoyed that kind of straddling of both worlds. But DreamWorks, they kind of wanted to,
silo you.
Silo you. So I decided to silo myself in the engineering area. And that's kind of where I stayed. So I stayed involved heavily in production, and I sat with the lighting artist to make sure I was always aware of what they were doing. But I really focused on, tool sets. and making Nuke work better again in a feature animation environment. So
Yeah. It's so that's interesting. So over 10 years at DreamWorks, a lot had changed obviously in terms of hardware and software
Oh
and
yeah.
capabilities and production and everything.
Yes.
What were some of the biggest challenges that you had in from that perspective over those 10 years? Like, what are some of the memorable challenges you had?
There were quite a few. One was how to make Nuke handle large production assets.
Okay.
Well, for example, Nuke's 3D system, when I originally wrote it and designed it in digital domain, we wanted to do cards and cubes and spheres and not much, and maybe a little object or two. That was about it. Hundreds of faces, not millions of faces, right?
Right.
And so when I got to DreamWorks, they wanted to project on production assets. They wanted to project textures on production assets, which had millions of polys, right? Millions of faces. And Nuke was just like, it
Right.
was not designed to do that. So I ended up re-engineering a lot of those tools and writing a new renderer, ray tracing renderer, which would handle that stuff very efficiently. So that was a lot of what I did was make customized Nuke's tool set to handle those kinds of procedural large environments. Working on defocusing, that was a huge job. Making defocusing more
Right.
accurate so that they would get better simulations, and that was a big deal. Yeah, there was there was a lot. Making layers. So when they got into doing a lot of AOV difference subtractive modifications for lighting, right? So to increase the
Okay.
speed of their lighting, they wanted to be able to take the beauty render, subtract, say, a light's diffuse contribution, modify that light's diffuse contribution, then add it back in again.
Okay.
And Nuke, you can certainly do that, but you need to wire up a network to do it, which
Sure.
was very inefficient. So I ended up writing a lot of like layer management tools, so that artists could do those kinds of subtractive modifications, like they did all the other kind of modifications that they did in Nuke. So yeah, there was a lot of
Interesting.
tools. Yeah.
Now, I mean, DreamWorks, did you guys get the source code of Nuke to be able to modify Nuke? Like, how is that possible? Or
No.
did you just write a bunch of
These are just
plugins
plugins.
or?
Yeah. In fact,
Wow.
yeah, people take for granted that that's available, but in Nuke 2 there were no plugins. So Nuke
Right.
2, if you added a new color corrector, you had to recompile the entire program.
Right.
So,
Yep.
so having plugins and the ability to write plugins was a huge boon for Nuke 3 and beyond, and that allowed me at Image Movers and at DreamWorks to really extend Nuke way beyond what it was originally designed to. Break it, in for lack of a better phrasing. Yeah,
Right.
you can. It's amazing what you can do. There are definitely limitations, but you can get an awful lot done by writing plugins.
Yeah.
So
Yeah. Yeah. And so as you mentioned, or you left DreamWorks about 2 years ago, and now you're at the Foundry, right?
yes, yes. So
So tell me a little bit about that. Obviously, Nuke is a much more, it's just as special, but much bigger as it was back in 2003 when you and I were working on iRobot,
Yeah.
but how, like, what is going on with Nuke right now? I mean, it is doing some really interesting things.
Yeah, I mean, Nuke has evolved tremendously since 2008, which is when the Foundry took that code base over. A lot has
Right.
changed. I mean, they added stereo, they added deep, they added more roto tools. And of course, they added the studio timeline interface on top of it. But what hadn't changed was some of the core architecture left over from Digital Domain, and specifically the 3D system. Like,
Right.
so all that stuff, all that work I did at DreamWorks, essentially hadn't been done for Core Nuke. And it
Okay.
was showing its age. It was showing its age when I went to DreamWorks, and so by the time
Right.
the end of the 2010s came along, it was really showing its age. So yeah, it was really I guess COVID kind of made that happen
Okay.
because the idea of working remotely for a company in London wasn't particularly appealing to me.
Right.
Because DreamWorks is a very comfy place, so I got used to
Right.
the very comfy environment of DreamWorks, especially that campus in Glendale, and I enjoyed it. And and I didn't think that I could work from home all the time. So, but COVID kind of forced that on us all. And after
Right.
doing 6 months of that at DreamWorks, working from home, I realized, okay, I can do that. So that was really the change was allowed that to happen. So when they
Interesting.
came knocking, asking, was I interested in helping, revamp the 3D system,
Right.
it was a good time. So I did that November of 2020, I think.
Okay.
So it's been a little over 2 years.
Yeah. So we had been in the pandemic for a while when that happened, and you started like, okay, I can make this happen.
Yeah, it was literally like 6 months in. I realized it's not comfortable. I don't like it necessarily.
Sure.
It isn't the best, but I can manage. I figured out how to
Right.
manage by that point. And for example, I'm in my basement in a relatively it's not exactly a nice office, but I was working out of my I was working out of my bedroom for a good year, So
Yeah.
I'd wake up and the workstation's attached to the wall on an arm, I would just kind of swing it over,
Yeah.
take a shower, walk out, start working. Yeah.
Yep.
Yeah.
I'm still working out on my dining room right now.
Oh, there you go.
It looks nice behind me.
Exactly.
It
Okay.
works.
So
Got
it
my little
looks
Willie
nicer than
Nelson
this.
up
I have
there.
to get some posters and something. Maybe paint the wall.
It's funny. You know what is funny is seeing how people have decorated their lives behind them. Like
Yes.
there's someone who strategically puts their guitar collection behind them,
Exactly.
which I always thought is
Yep.
kind of funny. But yeah, so that's really interesting. Now, there's been some interesting research in different areas that Foundry has been trying to take Nuke, and one of the things I was doing, doing Chaos Labs, and one of the areas I was looking at is some areas of virtual production and some of the things going on, specifically with interfacing with Unreal. And I know that you guys were working on something interesting with interfacing with Unreal as well. Just to make sure that I get this story right, I think it'd be better if you tell me what exactly are some of the efforts that Nuke is doing in terms of that interface with real time.
I probably can't say with certainty because even I'm not that involved in that part of it. I've been very, very focused. But I know that the Unreal Reader was beta for a while, I think in Nuke 13, and then I think it's released officially
yes, I
in
think
Nuke
that's
14.
Correct.
To be honest with you, I don't know enough about it to even comment. I do know that you get a connection to the Unreal Engine via a network connection, and you can do operations with AOVs and the things that you can't do easily in the Unreal Engine interface itself.
Yeah.
But
it's a live linking tool, which is really cool. And I've always sort of been fascinated with Nuke as not just as a compositor, but as a really interesting viewport. Which is what
you and a lot of other people.
Yeah, I think
yeah.
I mean, but this is not to diminish what it does in compositing, because the compositing is what makes it such an interesting viewport,
right?
In a lot of ways,
right. Well,
but it's got such a great way to sort of think about, how to see things.
Right. Yeah, and a lot of that has to do with the fact that you have all those channels, right? And the ability to manipulate
Yes.
layers so easily. And that's some of the things that you don't get with a lot of other systems. And that's
Hmm.
part of the major attraction of Nuke. But yeah, the connection, the real-time connection, there's a lot of synergies there, like Katana, being able to connect Nuke and Katana together to have them share data real time. There's a lot of opportunities there to really make the lighting experience better, certainly, because even at DreamWorks, there was a lot of interest in how can I get these, because the lighting artists would spend half their time or less in Katana and half their time or less in Nuke, depending on what they were doing, but they both
Right.
usually had both applications up simultaneously, too, because
Sure.
one each wouldn't do the whole job. So there's a lot of
Right.
opportunities for sharing data between DCCs like that. Certainly, Nuke will never do what Unreal Engine does. Likely, I
Right.
shouldn't say that. They're intended
Right.
for they're tools intended for different purposes, right?
Sure.
But there's certainly ways that we can connect them together, like you saw with Unreal, that really add a lot of value. So,
Right.
yeah.
Right. Well, that's interesting. So what are some of your thoughts? I mean, obviously that was a little peek into an interesting window of what Nuke is thinking about in terms of the future, and I think that's a very clever way of doing it because for me it was more of, well, real time is really great, but again, you're stuck with 4 channels, or better yet, only 3 in most cases, right? And so suddenly going back to that the power of more than 3 or 4 channels
Right.
into Nuke sort of became an interesting, like, okay, well, what if real time could have 64 channels or whatever it is, right?
Yeah.
And so what is the next level for Nuke and Foundry in terms of thinking about computer graphics and where you go from there?
That's a big. That's big. Well, certainly, with Nuke 14, we have added a USD architecture
Yes.
into it. So that opens up a lot of opportunities for us to do a lot more complex scene work. And in terms of real time, being able to visualize scenes based on USD, right? So there's a lot of USD visualization that you can do there. Yeah, I mean, yeah, real time is tricky.
Right.
Making Nuke work faster is always a major goal, and because that fits right in with the real time work. So if you can't process the data quickly, it's certainly not real time.
Right.
So adding the capability even more of Nuke being able to do processing on the GPU, processing color data through the GPU with more than 4 channels. There's a lot of opportunities there. It's probably never going to be a full GPU compositor, just because there are, just like in the Flame, where we discovered we had to move from Flame to Nuke because Flame's hardware couldn't do certain things. When we hit the limits of the Flame hardware, we then took a massive speed hit and having to do things through software. So Nuke, we took the opposite tack. We said, well, we'll just say everything with software and not attempt to accelerate via hardware, and then we can duplicate, right? We can get a lot of CPUs working on the problem. So there's a balance in there. There's a balance
Right.
there where these days you can do so much more with the GPU, but you still have limitations. You still can't do massive resolutions, for example, that you can do in software, or you can't do some of the more complicated operations. Certainly not with multiple channels. So I don't know. I'm kind of kind of wandering here. But
Yeah, I think you're absolutely right. I mean, Chaos has been working on GPU side of things for a long time, and we've had huge successes in those areas. But I think you're absolutely right. We are, even though we've been doing GPU stuff since 2008, the CPU doesn't seem to be going away either. It's like there's still a lot of things we need to take care of, right?
Right.
On the CPU side of things. So, which is a fascinating thing. Now, you did mention USD, and I did,
Yes.
we talked briefly about the viewport and how I love I love that Nuke viewport. It's like home to me.
Yes.
But what about Hydra? Like, how is there things about thinking about Hydra delegates and being able to integrate Hydra viewport inside of the Nuke viewport?
Yes, that's in fact what Nuke 14 has. So Nuke's
Great.
Nuke's 3D viewport is Hydra.
There you
It's
go.
Storm specifically. It's
Okay.
yeah. So going forward, it will be 100% Storm. Right now, we have both the legacy 3D system and the new 3D system working in the package, so you can essentially switch back and forth. But yeah, what you see in the new 3D system in the 3D viewport is Storm. So going forward, even though we've prototyped this, but we don't have this released, is having Hydra delegates. So a V-Ray Hydra delegate,
Right.
Spitting out pixels into Nuke. That's definitely something we're very interested in doing sooner than later. And so that you can hook in whatever renderer you want, whatever production renderer you want. The main limitation.
The dream is actually you can do multiple ones. You can have do all kinds of renders at the same time.
That's true. The main tricky part for Nuke is getting those renders to work well in how Nuke wants to parse data, or how it wants to break up. It wants to break up the image into little tiles, which are really long and thin, called scan lines.
Yes. Yes.
Or a whole bunch of little thin tiles, right? It really likes to think that way. It's very efficient at thinking that way. But that's not the way a lot of renderers think. So that's probably the biggest challenge, is just trying to get the interface between how Nuke wants to think about image data and how a renderer wants to think about image data. But these days with ray tracers, it's a lot easier because you no longer have these kind of blocked kind of rendering that you had in the older days. You can do different shapes of hot tiles much more efficiently now. So there's a lot of,
But you can also do progressive or path tracing as well. How does Nuke handle path tracing? Yeah.
Well, it doesn't handle progressive, right? Because progressive means the entire image changes, right? And so so all the scan lines change all at once. So Nuke doesn't like to think that way. Nuke likes to think, when it outputs the scan line, it's done with that scan line, right?
Right. Gotcha.
So unfortunately, what it means is Nuke needs to keep like re-updating, update. So, but there's opportunities to help or to modify the architecture to help those kinds of workflows, and that's one of the reasons why I'm back. Well, I'm not back to the Foundry, but I'm at the Foundry, working on this is to try to figure out some of these new workflows.
What are your thoughts? I mean, obviously, we were at DD during the emergence of EXR, when we had to move away from all these proprietary systems to this very promising open source, very elaborate EXR system that was daunting but exciting at the same time. Do you feel the same way about USD?
Yes, exciting and daunting.
Yeah.
It's extremely powerful, but also extremely complicated. And so a lot of getting used to USD is learning how it wants to think. Right? It wants to think in a certain way, and you just it's this process of learning how to fold that technology into something like Nuke and how to get them to behave, because Pixar didn't necessarily design USD to work in a procedural graph system like a Houdini or a Nuke or a Katana. So there are challenges with that architecture. So yeah, we're diving in head first, and we've gotten really, really far. But there's still a fair amount of learning and adapting to do. So it's a big challenge.
Awesome. Yeah. Well, I'm very excited about it. I think, it's about time we got away from the crutches of FBX and all those other horrible systems, which is cool.
Yes.
Well, listen, this is very exciting. We've wrapped up for about an hour, and I just want to, if there's anything that you can tell people to get excited about, what, could they look forward to and seeing what's happening at the Foundry, what's happening soon, and anything they can be excited about?
Well, certainly copycat in machine learning is one of the biggest areas that has got everybody really excited. And so there's the research division at Foundry has been doing an incredible job of getting those tools working inside of Nuke. And there's a whole, it's just the beginning of what can be done with those kind of systems. And so there's the exploration that's going to happen in the next few years when it comes to either doing roto or smart rotoing or who knows what people are going to think of to do. It's just the beginning of what if we can do, what if we can key, what if we can, render who knows what. So yeah, that's one of the most exciting areas, and that is going to just explode in the next few years.
Yeah,
So,
yeah, it's interesting. It's been a roller coaster of emotions and excitement and fear and
yes.
and everything that's going on with machine learning right now, which I think is really a big deal. I mean, and I'm
Well,
sure that what we're doing is going to be very important to explore those things.
I think in this context, it's really a perfect tool because you're not attempting to necessarily use the creativity, right? You're not trying to simulate necessarily the creativity of human mind, which is all this, stable diffusion, all that is trying to synthesize that or text. It's more about replicating what you can do with your visual system. Your ability to roto something, your ability to get rid of a wire and see that wire over time. Those are always the most difficult things to do for us as humans, but we're really good at it. Our visual system is really, really good at that. So having machine learning open up those opportunities to really take that to the next level, because optical flow is what we had done before, right?
Yep.
And optical flow is like Russian roulette. It's like one time it would work great, and maybe the next time it works okay, and then it fails, and then it works again, right? And so we all kind of went through that optical flow stage going, oh gosh, it's great, but my God, if it would just be, it would be more work reliably, right? That's I think the main hope here is that machine learning will allow you to increase that reliability so that it's not so much about a Russian roulette. Will I get a good result? So there's just a huge opportunities there.
Yeah, absolutely. I think you brought it up, and bringing up optical flow is a perfect way to put it, because the thing is, we're seeing a lot of really interesting things like, automatic masking and things of that nature, right? But we're not seeing good temporal stuff, right? Not seeing really and optical flow was sort of like, oh, temporally it's much smarter, right? Up to a point. But now I'm starting to think machine learning is getting better at temporal exercises that I think is really cool. And especially when you think of it in terms of roto and even infilling, right? Or in painting.
Yes, in painting.
And what,
In painting,
So
yeah, exactly. There's lots of opportunities, lots of areas for growth, and it kind of is almost the perfect, our brains are our visual system. That's how our visual system works, right? So, it's an excellent application of that technology. I'm not sure writing texts or children's stories is a great application of that technology, but this is.
Well, it may be to a point. I don't know. I've had several conversations about this. I'm very supportive of the debate that's going on in terms of people's worries and concerns about copyright, et cetera. Something that needs to be debated in the proper context of a courtroom, which I think is the perfect place to figure out what that is.
Right.
But at the same time, I will tell you this, just from trying to be a little bit of an optimist about it. I have never seen so much excitement about art
Yeah, well, that's a good point.
than now, right? People are so excited about making art more than I've ever seen anywhere else, to the point where now there's just this huge demand for people making images everywhere.
Right.
And then so it's like, to me, that just, that makes me happy. Well, be it, tackle the ethical issues and legal issues as it may, but the excitement over art and creativity is at a booming level, and to me, I was like, that to me just sounds positive. So,
well, that's very exciting. Yes.
Yeah. Well, awesome. Well, thank you so much, Jonathan. This has been absolutely great having you on. You, I think, are my second person from Foundry to come on. Jody was on.
Jody Bannon?
About 2 years ago.
Oh, okay.
3 years ago.
That's right.
Yeah. Really early days of the pandemic. So Jody was on. And yeah, so you're the second person to be on, which is very exciting. So both people that I met at the so there's definitely some strong roots of Nuke and Digital Domain.
Right, that's true. Yeah, she was part of that Digital Domain 2.0 group.
She was,
right.
and she's a brilliant business person, and I really appreciate how she runs the business. So
absolutely.
Well, cool. Well, thank you so much, Jonathan. I really appreciate it. And
no worries.
We'll look forward to Nuke 14 and 15.
Yes, exactly.